Welcome to VBM mathematics classes. Today I am going to discuss the increasing and decreasing. Now this increasing and decreasing is one important application of the derivative. Now first let us see the increasing. Now y is equal to fx, I am taking one function. For all x1 comma x2 belongs to the domain, D is a domain, that domain written closed interval a comma b. Now in that domain let us see whether how it is increasing. Writing the increasing, right? If you see the graph of this one, going upward, it is moving, again going upward, this function is called increasing, right? From left to right, this graph is going upward, therefore this is a strictly increasing. Now here it is not strictly increasing, whatever the graph here also same. Now for increasing let us see, x1 comma x2 belongs to the domain, x1 less than x2, this implies f of x1 less than or equal to f of x2, then that function is increasing. Now here I am taking the x1, here I am taking the x2. Now this is the f of x1, this is the f of x2, see that. Now x1 less than x2, x1 less than f of x2. Now therefore x1 less than x2 in its domain, right? This implies f of x1 less than or equal to f of x2. Here maybe less than or equal to f of x2. Suppose if I take x1 here, f of x1, f of x2 both may be the equal. This called only increasing, not decreasing, right? This is a increasing, in the bracket not decreasing. We can say not decreasing. Now here, what about this condition? This is a necessary condition and also sufficient, right? This condition is necessary. This is a necessary condition and also sufficient condition. Okay. Now if we take the derivative, suppose this is a fx. For fx I am drawing the tangent. The tangent is what? This inclination is less than 90. Therefore tan theta is called tangent slope. Tan theta is positive number. What is the tan theta? Slope. Slope called f dash x. Therefore greater than 0. Suppose it is only increasing, therefore here f dash x may be 0 also. Therefore, or we can write one more condition, that f dash x is greater than or equal to 0. This is only necessary condition, right? It is not sufficient. This is only necessary condition. Okay. Now let us see the strictly increasing. Let us say the strictly increasing. Now this graph is the strictly increasing. This is the y is equal to fx. Right? Take any 2 points like this, x1, x2, f of x1 less than f of x2. Right? x1 comma x2 belongs to, for every x1, x2 belongs to domain. If x1 less than x2, this implies f of x1 only less than f of x2. Then fx is strictly increasing. Strictly increasing. Now this is called a necessary and a sufficient condition. This is a necessary and also sufficient condition. Now r dash x is greater than 0. Now see the tangent slope, tan theta is greater than 0. Why? Because this inclination is less than 90, tan, therefore f dash x is greater than 0. Right. Or in some cases f dash x also may be greater than or equal to 0 possible. This is the only necessary condition. Okay. For example, why f double dash x is greater than 0 for strictly increasing? For example, I am taking the fx is equal to x cube. Fx is equal to x cube. If you see the graph of this one, the graph is like this. This is a x cube. Okay. Now, if you find the derivative of this, what is f dash x? F dash x is 3x square. Okay. Now, this is greater than 0. Why? Because square number always positive number. Now, here in the domain x equal to 0 also there. Keep x is equal to 0, it is also equal to 0. Now, though this function is strictly increasing, that f dash x is greater than or equal to 0 also possible. Now, let us see the decreasing. Now, decreasing, right, for every x1 comma x2 belongs to the domain, in the domain, if you see the graph of this, like this, and again it is moving like this. Now, this graph, if you see this one, this is a decreasing graph. This is now, if you take here x is equal to x1, this is the f of x1. If I take here x2, this is the f of x2. Now, if you see this one, this fx1 is greater than f of x2, right? Therefore, x1 comma x2 belongs to the domain. If x1 less than x2, this implies f of x1 greater than or equal to f of x2. Then that function is a decreasing. Now, this is a necessary and a sufficient condition. This is necessary and a sufficient condition. Right. Now, if you see the tangent slope, suppose I am drawing the tangent for this. For decreasing function, I am drawing the tangent. Right. What is the inclination of this one? This angle is more than 90. Okay. Now, theta is more than 90, it is in the second quadrant. Therefore, tan theta less than 0. Tan theta means slope less than 0. Slope means f dash x. Therefore, dash x is less than 0. Now, suppose here it is like this horizontal, that the slope may be 0 also. Therefore, or we can say one more condition for decreasing, f dash x is less than or equal to 0. This is only necessary. This is only necessary condition. Now, let us see the strictly decreasing. Now, let us see strictly decreasing. Now, let us see the strictly decreasing. For all x1 comma x2 belongs to the domain, for every x1 comma x2 belongs to the domain, if x1 less than x2, this implies f of x1 only greater than f of x2. Then the function is strictly decreasing. Now, here this is a necessary and also sufficient. This is a necessary and also sufficient. Okay. This is a strictly decreasing graph. Therefore, f dash x is always less than 0. This is another condition, f dash x always less than 0. Or there may be the possibility sometimes f dash x also less than or equal to 0. Like in the strictly increasing, f dash x is not only greater than 0, f dash x also greater than or equal to 0 possible. By example, fx is equal to x cube, we have taken in the last example. Same way, in the strictly decreasing also, right, f dash x is not only less than 0, there is a possibility that f dash x is less than or equal to 0. For example, same example if you want we can consider. Now that I am taking f of x is equal to minus x cube. Okay. What will be the graph of minus x cube? That graph will be like this. Okay. That is a minus x cube. Right, y is equal to minus x cube. Now if you find the derivative of this, f dash x is equal to minus 3x square. Okay na? And this is a less than 0, y x square is a positive, before the positive number minus sign is there, that's why less than 0. Okay. Now in the domain 0 also there, if I write 0, it may be equal to 0. That's why for strictly decreasing, that f dash x not only less than 0, maybe f dash x less than or equal to 0 possible. Now next let us see the monotonic function. What is a monotonic function called? Now if you see the graph of this one, this graph is strictly increasing, right? Every strictly increasing function is a monotonic increasing function. We call it a monotonic increasing function. This is a monotonic increasing function. And if you see the another graph, this graph is strictly decreasing. Strictly decreasing, that is called a monotonic decreasing function. This is called monotonic decreasing function. Right. Now either strictly increasing or strictly decreasing, that function called monotonic. The monotonic function nothing but either strictly increasing or strictly decreasing, but not like this. This graph is like this, it is increasing again coming down. This is neither increasing nor decreasing in its domain. Domain is from here to here. Now in its domain, this function is neither increasing nor decreasing. This is a not monotonic function. Now these two functions are monotonic functions. Y is equal to fx. This is another different function, y is equal to x. Now the function in its domain either increasing, strictly increasing, either strictly increasing or strictly decreasing. Or strictly decreasing called monotonic. Right. Now this function is strictly increasing, this function is strictly decreasing, these two are the monotonic. This is not monotonic. Okay. Now let us see some examples. They given. This is a sine graph. Now in its domain, it is neither strictly increasing nor strictly decreasing. This is not monotonic. Now if I see another one, this is a sine x graph. Suppose I am taking y is equal to 1 by mod x graph. What is a 1 by mod x graph? This is a 1 by mod x graph. Now what is the domain? Domain from minus infinity to plus infinity except 0. In the domain 0 is not there. Right, from here to here in its domain except 0, right, it is increasing here, it is again decreasing here. Neither increasing nor decreasing, right? Therefore this is not monotonic. Okay, in the domain it must be completely always increasing or it must be completely always decreasing, then it's called the monotonic. but it is neither increasing nor decreasing. In one part of the interval increasing, other part of the domain it is decreasing. We say it is neither increasing nor decreasing, it is not monotonic. Now let us see another graph. They given the function like this. Here this graph is going upward, here it is empty, and started here the graph is going like this. Now whether this is strictly increasing or not? Yes, it is strictly increasing. Therefore this is monotonic. This function is monotonic. Now next let us see the monotonic increasing, monotonic decreasing at a particular point x equal to a in the domain. Now y is equal to fx, that at x equal to a belongs to the domain. Graph we are writing like this. This is a graph, it is a monotonically increasing. Strictly increasing called monotonic. I am taking x equal to a in the domain. Now this is a less than a minus h, where h is a positive number, just a fractional positive number, 0.0001 like that. Now this is a minus h less than a, this is a plus h more than a. Okay. Now if you see this one, this is a f of a minus h, this is the f of a, this is the f of a plus h. Now in the domain x belongs to a, at a particular point x equal to a, the monotonic increasing is f of a minus h less than f of a less than f of a plus h. Therefore this is a monotonically increasing at a particular point a. Okay. Now another condition, can we write f dash a is greater than 0 or maybe greater than or equal to 0? Not sufficient condition. Necessary and sufficient condition does not exist. That is why this is only necessary condition. For example, I am writing. Now if you see the graph of this one, this graph is going like this at x equal to a. This graph is like this, this equal to a. See that f of a minus h is this one, f of a is this dot, f of a plus h this one. Therefore this is a minus h, this is a plus h. Now see here, f of a minus h is less than f of a. Why? This is a f of a is here, this is a less than f of a, this f of a less than this one, this height is more. Therefore this is an example for the monotonically increasing. Now this condition can be write here f dash a. Why? Because here break in the graph at x equal to a, that's why we can't find the derivative. But here it is a monotonically increasing, it's a monotonic, but f dash a does not exist. Here that f dash a does not exist. Though that f dash a does not exist, the function may be the monotonically increasing or function may be the monotonically decreasing. Now next let us see the monotonic decreasing function, that is called strictly decreasing function. Now at a particular a, from the left to right, the graph is like this, strictly decreasing, called monotonic. X equal to a, here this is a x equal to a minus h, here x equal to a plus h. This is a f of a minus h, this is f of a, this is f of a plus h. F of a minus h, f of a plus h. Now if you see this one here, this f of a minus h is greater than f of a greater than f of a plus h. Therefore, this is a f of a minus h is greater than f of a greater than f of a plus h. This we can write like this. Or also we can write the necessary condition only f dash a is less than or equal to 0. That f dash a sometimes may not exist. That is why it is only necessary. This is a sufficient also necessary. Okay. Now if you see the example, one graph like this. Now the graph is going like this, coming like this. Okay. Now if you see this one, this is a not monotonic decreasing function. Why? This is a x equal to a, this is a minus h, this is a plus h, this is a plus h. Now see that this condition must be satisfied. F of a minus h is less than f of a, is greater than f of a plus h. Okay, therefore this condition is not satisfied here. This is a not monotonically decreasing function. There is a not monotonic decreasing function. Okay. Now let us see the one example. This fx is equal to the given 1 by mod x. X belongs to domain. It is a domain. Domain is what? Domain is minus infinity to plus infinity except to 0. That is, a domain is what? The domain nothing but r minus 0. Okay. Now whether it is increasing or decreasing in its domain. If you see the graph of this one, this is a graph of this one. Now at x equal to 0, the function is not defined, 1 by 0 is infinity. Now in its domain from minus infinity to plus infinity, in one part of the interval increasing, other part of the interval decreasing, therefore in its domain that function is neither increasing nor decreasing. Therefore this is neither increasing nor decreasing in its domain. Okay. Same problem they given like this. Fx is equal to 1 by mod x, where x belongs to minus infinite to 0. In that interval, whether it is increasing or decreasing, whether it is monotonic or not. Yes, from minus infinity to 0, the function is strictly increasing. Therefore, in this interval, the function is a monotonic increasing function. Okay, now? Right. Therefore, this is monotonic increasing in this interval. Right. In what interval? In the interval minus infinity to 0. Okay. Suppose if they give the entire domain, in the entire domain some part it is increasing, other part it is decreasing. That is why neither increasing nor decreasing. We can't say it is a monotonic. This interval from minus infinity to 0, yes, it is a monotonically increasing function. Okay. Now let us see the composite function. Y is equal to fx and y is equal to g of x they given. Both have the same domain. Same domain. What about the composite function? This is h of x is equal to f circle g of x or capital H of x is equal to g circle f of x. Now let us see that table here. That table I am writing. This is f x. This is g of x. Right. Now for increasing I am taking the symbol like this. Increasing, this I am symbol using. The graph from left to right moving upward, increasing. And decreasing symbol I am taking like this. Decreasing symbol I am taking like this. Sometimes the increasing symbol we can take the plus sign, decreasing symbol we can take the minus sign also. Why? Because now for increasing f dash x is greater than 0, positive. Now the decreasing function f dash x is less than 0, that's why we are taking the minus sign. Okay, increasing symbol either this or this, decreasing symbol either this or this one, right? Now here, now this is a composite function g circle f, this is another composite function f circle g. Okay, now this is the increasing symbol I am using the plus, this is also increasing. Then what about the composite? That composite will be like this, plus into plus plus. This composite f plus g plus, product of this plus into plus plus. Therefore f increasing, g increasing, g circle f also increasing, f circle g also increasing. Now suppose this f is increasing, g is decreasing. There is a plus into minus minus, plus into minus minus. Therefore g circle f decreasing, f circle g also decreasing, right? And this is a decreasing and g is increasing. Then minus into plus, minus, minus into plus, minus. Therefore g circle f is decreasing, f circle g also decreasing. Now if suppose both are decreasing, minus minus, then minus into minus will be the plus, g circle f is increasing, f circle g also increasing. Okay na? Now why we got plus into plus, that g circle f is a plus increasing, why we got minus into minus plus g circle f is positive increasing? That means first I am taking h of x is equal to g circle f of x, right? This is f and g both are differentiable in its domain, that condition is there. Now h of x, this h of x also written g of f of x, this h of x also written g of f of x. Now what is the derivative of this? H dash x is equal to g dash of fx into that inside derivative f dash x. Okay, how it is? This is g dash of capital X into f dash x. Okay, here what is let us see this one, let us see the last one. Fx is what? Decreasing. Okay, now if fx is a decreasing, then what about the f dash x? Minus sign. Okay, what about the g of x? It is also decreasing, therefore g dash x also negative. Therefore this product is what? Minus into minus plus, therefore it is greater than 0. Therefore now we got h dash x is greater than 0. Therefore h of x, this is what? G circle f, g circle f is a plus we got, therefore it is increasing. Okay na? This is a increasing. Therefore by this application minus into minus plus, that is why same application we are applying for all this. Now for example they given like this, fx is equal to sine of tan of cos x in the interval 0 to pi by 2. In the interval 0 to pi by 2, whether this is a increasing or decreasing or not. Cos in the 0 to pi by 2, 0 to pi by 2 cos is a decreasing graph. Okay, it is coming down from 0 to pi by 2. Decreasing means it is a minus. Tan is what? 0 to pi by 2, it is a increasing, plus. What about the sine in that 0 to pi by 2? It is also increasing, plus. Therefore plus into minus, it is a minus. Therefore fx is a decreasing. This fx is decreasing in the interval 0 to pi by 2. Now next let us see the critical points. Critical points. Y is equal to fx I am taking, Now x equal to a belongs to the domain, right? At x equal to a, that belongs to the domain. If f dash is 0 or f dash does not exist, then at x equal to a is critical point. X equal to a is called a critical point. What will be that point? That point is a comma f of a. For example, if you see this one, the graph is going upward like this. Right here, this is the x equal to a. Here, what is f dash a? Now, at this point, what is the tangent line? Horizontal. Therefore, its slope is 0. What is the slope? F dash is the slope. The graph is like this. It is going like this and again moving like this. Now, this is a x equal to b. Here, that f dash b does not exist. Right? There is a one corner point here. Therefore, here f dash b does not exist. Here, f dash b does not exist. Okay, now here f dash a is 0. Therefore, x equal to a is one critical point, x equal to b also called another critical point. Critical point also called turning point. F dash sign from here to here changes from plus to minus. Here at x equal to b, just less than b tangent slope is minus. Here just more than b tangent slope is plus. Right, f dash b sign changes from minus to plus here, plus to minus here. Therefore, if f dash sign changes at some point, that point is called a turning point or critical point also we can call. Okay, now let us see the example on this. Fx is equal to x minus 2 whole to the power of 2 by 3 into 2x plus 1. Find the critical points. Find critical points. Now, for critical point, find the f dash x. What is the derivative of this one? This is a product rule. 2 by 3 whole to the power of x minus 2 whole to the power of minus 1 by 3, 2x plus 1, x minus 2 whole to the power of 2 by 3 into 2. This is a 4x plus 2 plus 6x minus 12 by 3 into x minus 2 whole to the power of 1 by 3, 10 into x minus 1 by 3 into x minus 2 whole to the power of 1 by 3. Now, if you see this one, this f dash x is 0 where x is equal to 1. If I write here, that is a f dash 1 is 0, put x is equal to 1 here. This f dash, what is that? At x is equal to 2, the derivative does not exist. Therefore, if I write x is equal to what will be this one? This is a infinity which does not exist. Derivative never be infinity. Therefore, f dash 2 does not exist. Does not exist. Therefore, which are the critical points? X equal to 1 is a critical point, x equal to 2 is also another critical point. Critical points are x equal to 1 and 2. Now, let us see the one problem. Fx is given like this, x upon sin x, and g of x is given x by tan x in the interval 0 less than x less than 1. Whether these functions are increasing or decreasing. Whether these increasing or decreasing. Now see the first one, fx is equal to x upon sin x. For increasing or decreasing, we find the derivative. F dash x is equal to what? F dash x is equal to x derivative 1 into sin x minus x into sin derivative cos x by sine square x. We got like this derivative. Okay. Now in the 0 to 1, x belongs to 0 to 1. 1 is less than pi by 2. 1 is less than pi by 2. Right. Now square number always positive number. What about the numerator? Now in this I am taking common cos x. Cos x is a common tan x minus x. Denominator is a sin square x. Now in the interval 0 to 1. 0 to 1, 1 is less than pi by 2 only. Therefore 0 to 1 it is in the first quadrant. In the first quadrant cos x is a plus and sin square is a positive. What about the tan x minus x? We know in the 0 to pi by 2 this is a sin x less than tan x. Therefore this is a tan x minus x will be the positive number. Therefore take these two, x less than tan x, x bring that side, tan x minus x. Okay. Now what we got here, the tan x minus x is a greater than 0 positive. Therefore this is also positive number. Right? Plus into plus, it is always greater than 0. Now f dash x is greater than 0. Right? Therefore this function is strictly increasing. Therefore this implies fx is strictly decreasing. Sorry. fx is strictly increasing. Okay. Now similar way can you solve the problem second one. Right. Now say the answer in the comment section. Now see the next one, gx is x upon tan x. Now whether this is increasing or decreasing, apply the same method. Right, tell me the answer whether it is increasing or decreasing in the comment section. Okay. Problem which is related to the increasing decreasing. When given if 0 less than alpha less than pi by 6, then alpha and the cosec alpha is what? Whether it is less than pi by 3, whether it is greater than pi by 2, whether it is lies in the interval pi by 3 to pi by 2, whether it is greater than pi by 3. Now which option is correct in this ABCD? Tell me in the comment section. Right, thank you everyone.